Hey everyone, and welcome back. Today, we are unlocking a seriously cool math hack, finding the area of a triangle using determinants. This is one of the most powerful tricks in the entire chapter, so let's jump right in.
Okay, picture this. You're in the middle of a massive online game, right? Your character unleashes this awesome triangular magic spell. How does the game engine figure out the exact area of that triangle, like instantly, to calculate the splash damage? It has to happen in a millisecond.
So, is there some kind of math cheat code for that kind of insane speed? A secret power-up, maybe? You bet there is. And that power-up is called a determinant. It's the perfect tool for getting the job done fast and with total accuracy.
All right, let's get straight to it. This is the ultimate tool, the main weapon for this mission. This is the cheat code we're going to master today.
Now, you've probably seen that long, kind of messy formula for the area of a triangle before, but here's the cool part. That whole thing can be neatly packed into this super clean, super organized determinant form. This is the real upgrade, because it's systematic, way easier to remember, and just better. Let's break this down real quick. Don't let it look complicated, because it's not. You've got 4 simple parts. First, there's always a 1/2 in the front. Easy. Second, you've got these bars for the absolute value, because, area can't be negative. Third, the main part, the matrix you build with the coordinates. And fourth, and this is the key, that last column is always, always just ones. That's it.
Okay, enough talk. Let's fire this thing up and use our new tool to solve a real problem. Ready for quest number 1?
And look, there's a simple 5-step game plan that works every single time. 1, list your coordinates. 2, build that matrix we just talked about. 3, find the determinant. 4, make sure the number's positive. And 5, multiply by 1/2. That's the whole recipe.
All right, let's grab a problem straight from the NCERT textbook to see this in action. We've got our 3 vertices, 1, 0, 6, 0, and 4, 3. Let's follow our 5 steps. Step 2, build the matrix. See how we just slot everything in? The X values, 1, 6, and 4, go into column 1. The Y values, 0, 0, and 3, go into column 2. And that last column, you guessed it, just ones. Super simple setup. Okay, time to crunch the numbers. We'll expand along the first row. Just remember that little sign pattern, plus, minus, plus. So we take the first number, 1, times its little 2x2 determinant. Then the second number, 0, with a minus sign in front. And finally, the third number, 1, with a plus sign. It's just simple multiplication and subtraction. And when we do all that simple math, we get -3, -0, plus 18, and that all adds up to 15. So the value of our determinant, delta, is 15. We're in the home stretch, the last 2 steps. We take the absolute value of 15, which is just 15, then multiply by 1/2, and boom, the final area is 7.5 square units. Quest complete. See how clean that was? So that was pretty straightforward, right? But what happens when our awesome formula gives us a really weird answer? Like, what if the area is 0? What does that even mean? So if you get 0 as an answer, is your first thought, oh no, I messed up the calculation? Well, guess what? It's not a mistake. It's not a bug. It's actually a hidden feature. The formula is trying to tell you something really important. And here's the secret it's telling you. If the determinant is any number besides 0, you've got a normal, healthy triangle. But if the determinant is exactly 0, it means your 3 points are so flat they don't even make a triangle. They're all lined up perfectly on a single straight line. The fancy word for this is collinear. So getting 0 is just the math's way of telling you the points are collinear. Okay, you've leveled up. You've mastered the main skill. Are you ready for the boss level? Now we're going to flip this whole thing around. We're going to find a missing coordinate when we already know the area. So in this new challenge, we actually start with the final answer. We're told the area is 4 square units. Our job is to work backwards and find a missing piece of the original puzzle. And here's our boss level problem, again from the NCERT exercises. We have the vertices k, 0, 4, 0, and 0, 2. The area is 4. Our mission, find the value of k. Now listen up, because this is the #1 trick that everyone forgets. Because the formula uses an absolute value, the determinant inside those bars could have been positive or negative to begin with. So if the area is 4, that means the value of our determinant, delta, multiplied by 1/2, could have started as +4 or -4. We have to check both possibilities.
So let's set it up. We build our matrix, we calculate the determinant, and it comes out to the expression 2k minus 8. So our equation is 1/2 times the absolute value of 2k minus 8 equals 4. Let's just multiply both sides by 2 to make it cleaner. That gives us the absolute value of 2k minus 8 equals 8.
Now we just solve our two cases. Case 1, what if the inside was positive? So 2k minus 8 equals positive 8. A little bit of algebra, and we get k equals 8. Okay, case 2, what if the inside was negative? So 2k minus 8 equals negative 8. A little more algebra, and we get k equals 0. And look at that, we have two completely valid answers for k.
And you did it! Boss level cleared. Fantastic job. Before we sign off, let's do a super quick recap of the cheat codes we unlocked today.
Just remember these 4 things. 1, the formula itself. Area is half the absolute value of the determinant. 2, the zero glitch. If the determinant is 0, your points are in a straight line. 3, the absolute rule. Area is always positive. And 4, the boss level trick. If you're given the area, you have to solve for both the positive and negative cases. So you now have this amazing tool for finding the area of any 2D triangle. Which leads to a cool question. How do you think we could level this up? Could we use the same idea, plugging coordinates into a determinant, to find the volume of a 3D shape, like a pyramid? Something to think about. I'll catch you in the next one.